Hi everyone. Today we're going to study areas of combinations of plane figures. Let us now try to calculate the areas of some combinations of plane figures. We come across these types of figures in our daily life and also in the form of various interesting designs. Flower beds, drain covers, window designs, designs on table covers are some of such examples. Example 1. Two circular flower beds have been shown on two sides of a square lawn ABCD of side 56 meters. If the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn, find the sum of the areas of the lawn and the flower beds. This is our figure. Analyzing this figure, we can see that the total area that we need is the area of square plus 2 times the area of the segment, which are the shaded areas. Let us first compute for the area of square, and that is S square. The side is 56 meters, so we substitute it here. We have 56 square, and that is 3,136, and the unit of measurement is square meters. Then the area of segment, and the formula is area of sector minus area of triangle. In this case, let us separate the computation of area of sector from the area of triangle. Let's begin with the area of sector, and this is the formula. The theta is the central angle 90 degrees, and the radius is not given. We need to solve first. Now let us draw a perpendicular bisector for the angle 90 degrees. So we will have 45 degrees on each side. And also the side AB, which is 56, is divided into two. One is 28, the other is 28. We have here now one small right triangle, and we can solve for R. And that is sine 45 degrees equals 28 over R. The value of sine 45 degrees is 1 over square root of 2. When we cross multiply, we will get the value of R as 28 square root of 2. So this value we can substitute now here. We have now 90 over 360 times the pi is 22 over 7 and the R is 28 square root of 2, that is squared. This fraction we can simplify as 1/4, and the square of 28 square root of 2 is 1568. We can use our calculator to simplify the product, and that will be 1232 square meters. We can substitute this value for the area of sector. Then let us solve for the area of triangle. For this triangle, we have the base as this AB, and that is 56. We don't have the height, and that is we're going to solve. Consider the small right triangle here. We can write tangent 45 degrees equals 28 over h. The tangent 45 degrees is 1, and when we cross multiply, we will get the value of h as 28. So let us substitute now the values for the area of triangle. The base is 56 and the height is 28 divided by 2. That will be 784 square meters. When we substitute this value in here, we will get the difference as 448. This is the area of the segment. So we have now the area of square plus twice the area of segment that we will substitute in here. So 3136 plus 2 times 448. The product of 2 and 448 is 896, and the sum is 4032 square meters. This is our answer. Example 2. Find the area of the shaded region in the figure below, where ABCD is a square of side 14 centimeters. In our figure, we can see that the required area equals the area of square minus 4 times the area of one small circle. Let us first find the area of square. Our formula is S square. The value of the side is 14 centimeter, so that will be 14 square, and the answer is 196 square centimeter for the area of square. Now, the area of circle, that is pi r square. In our figure, note that the diameter of one circle equals 14 over 2, and that is 7. Therefore, the radius of the circle equals 7 over 2. And this value we will substitute for the r. We have now 22 over 7 for the pi times the square of 7 over 2. The square of 7 over 2 is 49 over 4. And when we simplify these fractions, the product is 38.5 square centimeter. So these values we will substitute in our formula here. So we have 196 minus 4 times 38.5. The product of 4 and 38.5 is 154. So the difference is 42 square centimeter. This is our answer. Example 3. Find the area of the shaded design below, where ABCD is a square of side 10 centimeter, and semicircles are drawn with each side of the square as diameter. Use pi equals 3.14. In our figure here, let us denote the unshaded areas as 1, 2, 3, and 4. So when we analyzed our figure, the required area is area of square minus the total of the areas 1 plus 2 plus 3 plus 4. Let us analyze our figure. This area 1 and area 3 is equal to the area of this square minus the area of two semicircles. And the semicircles are this AD and also this semicircle BC. So using our formula, the area of square is S square minus the area of circle divided by 2. This is the formula of semicircle. Then we multiply by 2 because we have two semicircles. When we substitute the corresponding formula of the circle, we have pi r squared over 2 times 2. Then we can cancel this 2 by this denominator. So, this becomes pi r squared alone. We can now substitute the values. The s squared is 10, that is squared, minus the pi 3.14 and the radius. In our figure here, in the semicircle, the diameter is equal to the side of the square. Since the side of the square is 10, which is also the diameter, therefore, the radius is 5. That is why we write here 5. And when we simplify this, we have 78.5. And the difference is 21.5. And the unit of measurement is square centimeter. Now, looking at our figure, the area 2 and area 4 is equal to the area of 1 plus 3. That is 21.5 square centimeter also. It means to say the area 1 plus area 2 plus area 3 plus area 4 is equal to 2 times 21.5, and that is 43 square centimeter. Now, we can substitute this value of area in our required formula here. So that will be 10 square, that is the area of square, minus 43. 10 square is 100 minus 43, that will be 57 square centimeter. This is our final answer.